Hey guys, today we're going to look at the first step in a larger process of calculus for your first semester, and it's derivatives, okay? And to start using derivatives, we're going to use the formula that you see in front of you, and hey, guess what? We've seen this before. So let's just real quickly give a mathematical definition to a derivative, and that says exactly what this slide shows. The derivative of the function f with respect to the variable x is the function f prime, whose value at x is, and they give us this whole long thing, provided the limit exists. Well, we've seen this whole long thing before. We did it in some previous work where we were looking at how to find slopes of tangent lines. Well, that's going to be called a derivative. So let us differentiate f of x equals x cubed, and differentiate is a fancy way for saying let's take a derivative. So here we go. We need to know what our function is, and our function is f of x equals x cubed. We need to know what f of x plus h is. And so when we're working f of x plus h, we're just taking that x plus h and cubing it. And when we do that, what we're going to end up with is, I don't know, let's just do it in pieces. What if I did this right here? Isn't that the exact same thing as x plus h cubed? So then FOIL out the first two guys, and you're going to get x squared plus 2xh plus h squared times x plus h. And then everything in the front times everything in the back. And that's going to be x cubed plus 2x squared plus xh squared. Let's see here. This should be 2x squared h. Let me clean it up. We want to make sure we get that right. 2x squared h plus xh squared, and then do everything with the h's. So plus x squared h plus 2xh squared plus h cubed. Wow, that's a mouthful. And let's see, will any of these things go together? 2x squared, any other x squared h's here where I've got x cubed plus 3x squared h. So that takes care of this guy and that guy. I've got xh squared and xh, so plus 3x h squared, that takes care of these two, plus h cubed. Whew, that's a bunch. So now I do my limit process, which is this guy right here. And what we're going to do is we're going to take f of x plus h, which is everything that we just found. So x cubed plus 3x squared h plus 3xh squared, 3xh squared, plus h cubed minus f of x, which we were told is x cubed. And we always want to put that last part in parentheses. And then we're going to take the limit as h approaches 0. Well, on the top, some things cancel out, like this x cubed here and this x cubed here, and that's really great because that's what we want. And then that leaves us with 3x squared h plus 3xh squared plus h cubed. Everything we have left has an h in it. And so when we look at the limit as h goes to 0, check it out. I take out one h from every place, and this 3 becomes a 2. And what do I have left? I've got, and let me separate this out a little bit, I've got 3x squared plus 3xh plus h squared. And when I put 0 in for the h's, because that's what I'm looking at. I'm looking at the limit as h goes to 0. I'm left with 3x squared. So for this particular problem, we would say that f prime of x is equal to 3x squared.